All right. So mean value theorem. So we're going to talk about two theorems. So the first theorem is Rolle's theorem. It says let f be a function that satisfies the following three hypotheses. F is continuous. So the function itself is continuous on a closed interval between a and b. F is differentiable on the open interval between a and b, and that f of a equals f of b. Then there is a number c in the interval ab such that f prime of c is equal to 0. And basically, this is saying there should be at least one critical number between f of a and b if you have 2 points of the same in any function. So we're gonna do this. So you're gonna see two types of problems in this section. The first problem is you're gonna verify that something satisfies it and then find the numbers that it satisfy it. And the other one's kind of like a little word problem. So the main point of why we teach you these is that way you can identify things about functions by looking at properties. So let's do this. So verify this function satisfies Rolle's theorem. So here is this function. This is a polynomial. So I'm going to call this condition 1, condition 2, and condition 3, just so I have some things. So for condition 1, it's a polynomial, and polynomials are continuous in their domain. Are continuous. Well, they're actually continuous everywhere, right? So polynomials are continuous everywhere. 2. Polynomials are differentiable everywhere. Are differentiable everywhere. Three. F of A equals F of B. So we're going from 0 to 3. So what do? We just type in F of 0. F of 0 is equal to what? Well, that's real easy. It's 2, right? Because this is 0, 0, 0, and 2. F of 3. What is that? Well, just chunk it through a calculator, right? Let's do that. Let's do that. I'm going to use... Oh, you know what? We can probably just use decimals, and I can probably save myself time. So let's just save myself, because I want to show you the graph of it anyways, and it should tell me what a function value is at a certain number. So 3 minus x squared minus 6x plus 2. All right. So here we have it 0. It's equal to 2. And here at 3, it is, come on. Yeah, at 3, it's equal to 2, right? So it's f of 0 is equal to 2. F of 3 is equal to 2. So we show that it satisfied the conditions. How do you show that? It's continuous everywhere. Polynomial is continuous everywhere. It's differential everywhere. Polynomials are differential everywhere. These are things we've already established. We show that f of a, which in this case is 0, and f of b are both equal to, I wrote 3 there, and I meant to write a 2. Woo! On the wrong layer, too. It's equal to 2. So here we have that. So we verify there is a number. And then we want to find all c, which is this is the case. And so here, how do we do that? We set c. So we actually find the derivative, because we want to figure out where the derivative is equal to 0. So we find the derivative of this. The derivative of this is 3x squared minus 2x minus 6. We set that equal to 0. Oops, there we go. We set that equal to 0. So we have 3x squared minus 2x minus 6. What am I up to? Let me open up Wolfram Alpha real quick. So 0 equals 3x squared minus, hold on, make sure I write this correctly, 2x minus 6. Run through the values. And what do we get? We get, hi. Look at this awfulness. Why is it so awful? I just pulled this from one of your homework problems, so I wouldn't be a bit surprised if it is this awful. Notice that this is outside of our domain, so this negative, this is less than 1, but this is inside our domain. So here, we're going to have x is equal to 1. Hold on, I wrote it, and then I've already lost it. Come back. Come back. 1/3 plus the square root of 19 over 3. Okay, which is approximate. Let's give this an approximate. Can I have an approximation, please? Thank you. Which is approximately equal to 1.78. And does that match what we see here in Desmos? So here between 2 and between 0 and 3, we have this here at 1.78, which is exactly what we see in Desmos, right? Exactly. So here we have here we can see that we do have a local min. In this case, we do have a critical point, and this one happens to be a local min. And so that's the whole point of Rolle's theorem. Okay. And so this is the C which satisfies it. All right. All right. Let f equal to tangent of x. Show that f of 0 equals to f of pi. But there is no number c between 0 and pi such that f prime is c. Why does this not contradict Rolle's theorem? So let's look at tangent. Let's just graph the thing. We'll graph the thing and we'll use that to cheat for all our points. So tangent. Tangent of x. Thank you. So notice here that f of tangent of x and f of pi are both 0, right? So we want to show that these equal each other. So f of 0 is equal to 0, which is equal to f of pi, right? So if it's tangent of x, they both equal 0. So notice what do we have up here? Is this f is this? But why does it? But there is no point. Let's look at the graph. Look at the graph. There is no point here where the derivative is 0 between here and here. Now, why is that so? Why have I not contradicted my theorem? Does anyone have a guess? There's actually two answers I can think of off the top of my head. Why is this not contradicted? Why is there not anywhere there the derivative of the function equal to 0 here? I'll wait for someone to answer. Which one of these conditions were not met? Condition 3 definitely was met. Is condition 1 met? Is this continuous between 0 and pi? Everyone's asleep. Everyone's just long since gone. I'm talking to nobody. It is not continuous between 0 and a. So it's not continuous. And therefore it's not differentiable for that case. So why does this not contradict? Oops. Hello. There we go. Why does this not? Because it's not continuous. It's not continuous. Or f of x is not continuous in the interval between 0 and pi. It's not, mainly at pi over 2. And so this doesn't contradict it. Okay, so I'll leave that for a second, take a drink, and we'll do our last page and call it good. All right. All right, so here's the more popular version. So we call this the mean value theorem. So let a function satisfy the following hypothesis. So the first thing is the same thing as before. F is continuous in the closed interval, and 2, F is differentiable in the closed interval. And basically what it says is that there is a number C in A and B such that the derivative of C is equal to the average rate of change. And this is what the average, and this right here is the average rate of change. Okay. Because f of b minus a, so this is my change of this is my rise over run, right? So this is the average rate of change. And so basically what this theorem says, there's an instantaneous rate of change at a point which is equal to the average rate of change over the interval. That's all it really says. So you can write it this way, you can write it this way, they say the same thing. So the first thing we want to do is, you're going to see some problems like this, and we'll figure, oops, why can we not? So let's verify this, right? So here we're going to see some problems. I'm just going to say find all number I that should be there. C that satisfy the conclusion. So here we have x cubed minus x plus 2. And so we want to say, is this, so this satisfies 1. So here we only have to satisfy the function here satisfies the following 3 hypotheses. It should only be 2. Hold on. I shouldn't talk with my mouth full. Did I miss something? Hold on. Should that? Yes. This is a copy error. Because what did I do after I made this for the notes? I was like, oh, it's the same, and so I just copied the first over and forgot to give it a change to the 2. It should only say 2 hypotheses. If this is true, then this is true, right? So for 1, this is a polynomial. Polynomials are continuous, so polynomials are continuous everywhere, right? Continuous everywhere. All right, and 2 polynomials are differentiable everywhere. In fact, not only polynomials differentiable everywhere, they're infinitely differentiable everywhere, but we won't get into that. So this satisfies the first 2 criterion. Okay. So what do we want to find? We want to find all f prime of c such that this is true. All right, so what's the first thing we want to do? We kind of want to figure out what this number is. So let's calculate that number. So here we're going to have f of 2 minus, oops, f of 2 minus f of minus 2 over 2 minus a minus 2. So this is f of 2. If I plug in 2 into here, what do I get? I'll get 2, so this would be 8 minus 6, so that'd be positive 2 plus 2, so this is, hold on, let me double check that. 8 minus 6, which would be positive 2 plus 2 is 4, and then negative 2, this would be minus 8, plus 6. Minus 8 is plus 6, which gives us negative 2 plus 2 is 0, all over 4, which equals 1. Let me double check that real quick. Let me double check it. I just don't trust my math today. I just don't. Oops. I don't trust me typing in a computer either. So yeah, that's negative, it's 4 and yep, 4 and 0. Okay, so that's correct. So we have the average rate of change here is 1. Okay, so now what do we want to do? Well, we take its derivative because we want to figure out what f of c is equal to 1. So here we take the derivative of this function. So f of x derivative is equal to 3x squared minus 3. Yeah, that's it. And we set that equal, and then we set this equal to, so 1 is equal to 3x squared minus 3. So where is this true? Well, that's where, so here just move everything to one side. So we'll have 0 equals 3x squared minus 4. And then we'll move, I guess, yeah, we should have done this. Let's move the 3 over 4, and then we just have 4/3 equals x squared. That means x is equal to plus or minus the square root of 4/3. Okay. And so those are the numbers. So, so those are the c's. So technically, I'm solving for. I was going to be more correct in my notation. I'm going to say c squared equals that. Oops. Okay. Hold on. And the reason I want to say. And so that's how you find that. All right, and last one. Let's go through this. And so what do we have here? All right, so here, suppose f of 0 is -3 and f prime of x is less than 5 for all values of x. How large can f2 possibly be? So how would I even start this problem? How would I even start this problem? Anyone have a guess? I'll just think about it for like at least 1 second before I give you the answer. How would you solve this problem? No one has a guess. Fine. Let's just go through it. How would you blunt force trauma this? So pretend you didn't know the theorem, right? Pretend you didn't know the theorem. How would you blunt force trauma it, right? It's like f of 0 is 3. My derivative has to be 5 or less, right? And we want this to increase as fast as possible. Well, we don't know it's going to be equal to or less than our original c value. All right, so let me do it with the theorem, and then I'll show you, and then I'll explain how we can blunt force trauma it, right? So let's use the theorem real quick. So let's go ahead and use this version of it. These are the same things. So here we're going to start, and I want to figure out what f of 2 is, right? So we're going to kind of leave f of 2 here. So we're going to go from, so here we're going to have 2 minus 0 of f prime of c is equal to f of 2 minus f of 0. Now, do I know what some of this is? Yeah, I know what f of 0 is. That's minus 3. Um, and so let's figure out what we have here. We have 2 times f prime of c plus, oops, I done something wrong. Oh, so this is plus 3, right? So minus the minus 3 makes this plus 3. When I move it back over, this is minus 3 is equal to f of 2. But what do I know about f of c? I know f of c has to be strictly less than 5, right? And so if I set it to be met, or 5 or less, right? And so here, if I set this equal to 5, minus 3 is less than or equal to f of 2. So here, that gives us 10 minus 3 is strictly less than f of 2. And that means f of 2 is 7 or less, right? So the highest value you can get here is 7. Now, does that make a lot of sense? Let's think about this kind of in blunt force trauma mode, right? So this is a more elegant way of showing it. Let's just say, if you're just thinking about this, here I have f of 0 is a negative 3. The most my increase can be, right? This is how much your slope is or how much the function's increasing. The most I can increase that is 5, right? And so if I'm increasing at max of 5 at 5 every time, I can go up 5 and then 5, so I'll be plus 10. So negative 3 plus 10 would be 7. So that's kind of how it kind of crunches through. So that's how I kind of crunched it through in my brain. How do you do it more elegantly is you use the mean value theorem and saying, hi, this must be true. I know what this value is. I know how much we've changed. I know that this is bounded. This f of c cannot be greater than or equal to 5. And so when I plug that in, I swap this, put a 5 in here, and I put this has to be less than or equal to it because here I put in the maximum value. So this becomes less than or equal to, and then you solved it through. All right, well, that's the end of the notes. You only have a couple problem mean value theorem for both the homework and for the online. Definitely, they didn't have very much homework for you. So those two are, so the online's put together, the written part's separated, but you turn it all in at once anyways. All right, we're 5 minutes early. Do you guys have any questions, or are you guys just good to go? How do you know which values are your A and B? So your A is your lower value and B is your higher value. Technically, if you mix them up, it's okay, because here if I switch, if I have A minus B and put out a negative here, and then f of A minus f of B, and that would have another negative, the negatives cancel each other. So if you mix up your A and B, you're actually perfectly fine. For this one, it comes out in the wash, right? So, but usually your A is your value to the more left on the number line, and B is the value more right on the number line. Okay. Any other questions you guys might have?
I have a question.
Oh, go for it.
Could you do an example of Rolle's theorem with like the cosine or something like that, like the trig functions?
Oh, so if you have Rolle's theorem for a cosine?
Yeah.
Sure, I can do that in like 2 minutes real quick. So let's pretend we have f of x is equal to cosine of x, and I'm going to go from, I'm going to go from pi over 2 to pi, 3 pi over 2. So pi over 2 to 3 pi over 2, the function is, this function is 0 and 0, right? Because f of pi over 2, 0. F of 3 pi over 2 is 0. And so here we satisfy Rolle's theorem. Cosine and sine are infinitely differentiable and they're continuous everywhere. And so we have that. And then here we want to find f of x, or f prime of x is equal to cosine, or is equal to sine of x. Sine of x, where is sine of x equal to 0 between pi over 2 to 3 pi over 2? Well, that occurs at pi, right? So 0 equals sine of x. That means x is equal to, technically when you solve this out, if you remember how to solve trig equations, it's 0. It's 0 plus n 2 pi plus 2n pi, and then pi plus 2n pi. But we only care about what's in the domain. What's in the domain? Pi. And so here my f of pi prime, we'll see, is equal to 0, which satisfies the theorem. Okay. So for sine and cosine, you're going to have an infinite number of solutions. And remember, you have to find, when you're solving trig equations, you solve for the unit interval, so from 0 to 2 pi, and then you add 2n pi, and then for the theorem, you only choose stuff which is in your domain. Okay? Does that help? Does that make sense? Okay, well, class is over. What does f prime of pi equal to? 0. Sine of pi is 0. Sine of 0 is 0. So
What you wrote there at the end is a
f,
fraction, right? 0 plus 2n pi over.
oh no, this isn't a fraction. This is the two solutions. So,
Okay.
sine equals 0 for 0 plus 2n pi and pi plus 2n pi. So this isn't a fraction. The only one that exists the only one that we care about is what's in our domain. The only one in our domain here is